All right. Welcome to the UC Davis Science Speaks lunch, virtual lunch. My name is Heather Segali with the UC Davis Tahoe Environmental Research Center. To learn more about TURC, you can visit us at tahoe.ucdavis.edu. Before I introduce Chris, I just want to say that this evening, we also have another lecture that is in person and virtual that is Changing Snowpack, Hazards, and Backcountry Safety with Andrew Schwartz, who is with the UC Berkeley Central Sierra Snow Lab. This afternoon's presentation, as well as this evening's presentation, are both part of the Take Care Tahoe Backcountry Safety Awareness Week. And then tomorrow evening, we have another lecture, so it's 3 in 2 days, that is on true fir mortality, canaries of mixed conifer forests, with Beverly Buluan, I'm sure I'm saying her name wrong, with the U.S. Forest Service. Has everyone noticed all the dead and dying trees around Tahoe? And that is obviously a major concern. So there is our introductory information. Today, I would like to introduce Chris Smallcomb, who is a warning coordination meteorologist from the Reno office of the NOAA National Weather Service. So thank you so much, Chris. We've loved your presentations in the past and look forward to this one. And so go for it.
Awesome. Thank you so much, Heather. Great to be back. And I mean, wow, what a trio of presentations you got lined up. I wish we got young kids at home, so the evenings are always kind of tricky, but I'd love to be there for the one today. We talked to Andrew quite a bit with the Central Sierra Snow Lab, and then also tomorrow on the tree mortality. Most of you know I do ultra running, and I'm up in the mountains all the time around Tahoe, and it's just amazing the patches of dead trees that you can see. So definitely look forward to hearing more about that. So what's my role in the triple play here is to talk about what we expect for this coming winter, and then go from there, and some ways to stay weather informed. So again, I'm actually now the meteorologist in charge at the National Weather Service in Reno. They foolishly promoted me to supervise and run the office back in the summer. So I'm doing more administrative and supervisory type things. So we'll see how that goes. And staff could be in for an interesting ride with me at the helm. So I'm going to go ahead and share my screen here, and we'll just do the entire desktop there. It just makes it easy for me there. And let's see. Let's do the slideshow. Okay. So you already saw that picture. That's me giving one of my world famous weather briefings using nothing but the latest in science and technology with the 8-ball and the rotary phone. Yes, I am just old enough to know how to actually use and operate a rotary dial telephone. And yes, this one actually works as a backup. So the snowpack is doing really well so far. That's obvious. Just look out your window. It's doing really well so far. It's also been quite cold. And so what does all that mean for this coming winter with a third La Nina in a row? So lots of interesting stuff going on. October was pretty quiet, and then boom, November, and now into early December has been pretty busy. So this is a really nifty diagram from the NRCS, looking at the snow tells around the Tahoe Basin. So kind of looking at all of them kind of lumped together, and looking at the snow water equivalents as a function of month for each of the last water years dating back to 2000. You can see 2023's water year, which is the current one that we're in now. Look at that December, quite nifty there, pretty standing out, although not quite as big as last year. Remember last year, the big December that we had, but that was it. You can see here how it really just boils down to 1 or 2 big months really make or break an entire winter. Last year, it was all about December. 2019, it was all about January and February, really the same for 2017, the monster winter we had there. 2011, actually March was a huge contributor to that winter's overall success. So neat diagram. You can actually, the link there at the bottom, you can actually dive into each of the basins and snow tells and things like that to see it. But we're off to a pretty good start. Here's the snowpack across kind of the southwestern part of the western US. And the blues are where it's really good, over 200% of normal across most of Nevada, the Sierra, Northern California. Utah is doing pretty good, 150, 160% of normal there. They just got, actually, Salt Lake City, the airport, they're over a foot of snow now for today. They're having another snow event there today. And what's interesting is the Southern Rockies are actually kind of behind. from the San Juans, where the Hard Rock 100 is, on south into New Mexico. Definitely kind of a slow start to the winter season, but in a way that's sort of what we would expect in a La Nina situation. So this is looking specifically at Tahoe. This is that time series diagram of the snow water content in inches as a function of time. The green line is average around the Tahoe Basin, and then of course you see the various percentiles and extremes in the color shading. But the black line is where we are at. So we're doing fantastic. And in fact, one way of looking at it is we're about 1 month ahead of normal. So we don't want to, but if we were not to have another storm, we'd have enough money in the savings account, money in the bank, to get us to about mid-January before we intercept that normal line again. So that's good. That's great news. You always want to have a little money in the savings account, right? In case tough times come on. And we always know, you've been here long enough, you know that even in a big year, we'll have multi-week periods where it does dry out. That's perfectly normal. What we saw last year, though, was not normal, where the atmosphere just totally shut down starting really on January 1st. And so we really had to use what we had in the bank at that point. It's been pretty cold recently, too. That's another aspect to this winter that's also a little unusual is, ever since we had that really big cold front in late October, it's around the 22nd, 23rd of October, we went from warm fall to cold fall, and that's continued. We really, aside from, say, around very late November, we really have been near to below normal on temperatures. And that's the graph that you're seeing here is from our Tahoe City weather observation station. The blue bars are the range of the low and the high temperatures for each day. And then when those get into the red zone or the blue zone, those are warmer than normal and cooler than normal, respectively. Well, you see quite a bit of that stuff is into the blue area. In fact, this one, I forget what date this was. It looks like it was around the 2nd or 3rd of December. Record low, new record low at Tahoe City. So all this data put together, if you look at the October 23rd through December 12th period, all the way back to 1909, this is actually the 3rd coldest on record this year. So if you thought it's cold, yes, it is. And actually is the coldest since 1972. That was also another very cold start to winter. So we're all in this boat together. I'm sure all of you have gotten these notices on your utility bills. And I got this from NV Energy, and I was like, oh, thanks for the tip. It's like the bill's already here. It's not giving me really any advance notice that it's going to be high. It's already high. So yeah, and that's definitely a ramification to this. And we'll see what the outlook has if maybe your bill might get a little bit of help here in the coming week. So another interesting aspect of this winter versus last winter is the character of the precipitation. I already mentioned it's been a lot colder than normal since late October. So you'd think, okay, we probably had a lot more snow. And you would be right. This is a picture from Chad Blanchard with the Water Master's office of the Tahoe City observation site a few days ago, just buried in that wet snow. And notice how the snow is piled up on that narrow chain link fence line there. Those things aren't that wide, but yet the snow is able to pile up because it was so wet and sticky. Which also goes to the power outages that the region saw. It was the wind plus that heavy, wet, sticky snow getting onto all the utility lines and whatnot. So, this is almost a worst case scenario for power issues with that wind and the wet, sticky snow. So let's look at this year versus last year. So what you're going to see here is a matrix showing you the percents of normal for rain and snow. So let's add all together. And then on the bottom row be just snowfall. So for this year at Tahoe City, we're above normal on the rain and snow. No surprise there, 123% of normal. But look at that snowfall number, 348% of normal. So this is the snowfall. So we're accumulating everything we've received, even the stuff that melts once it hits the ground. So that's why this number is a little different than those snowpack percents of normal, because the snowpack is like the total that's sitting on the ground right at this point in time. So, but still, just dramatic increases in snowfall just because of the cold temperature. So when we did get storms, they were snow. Look at this last year at the same time. We were more above normal on the rain and snow, but we were actually below normal at Tahoe City on the snowfall to date. So that indicated that we had a lot more rain last last year for the first part of winter that we had this year. So this has big ramifications for flood risk and runoff. So going into this winter, the soil is underneath is moist, but it's nowhere near as wet as it was this time last year because of all those the rain events that we had last year. So, last year we were at high alert for potential flooding just because the ground was so wet from those rain events in October and then again in November and December. This year, we're always at some alert status when we have a snowpack this big for flood risk. But another mitigating factor this year is the snowpack is so deep and it's cold. It's got a lot of absorptive capacity. It's like a giant sponge, if you will. And so if we were to get a big rain event, an atmospheric river event, a lot of that rain would actually go into the snowpack like a sponge and not necessarily immediately run off into the river. So it would actually take some time for flood issues to occur. So, our flood risk, if you say low, medium, and high, I'll say low to medium at this point, unless we started getting a series of those really wet, rainy atmospheric rivers, then, okay, we'd have to reevaluate that risk. For snow runoff, as we head into the spring, one thing that was interesting about last year is because of those rain events that we had in the fall, that moistened up the ground. And so the snowpack that we did get, which ended up being near to maybe just a little bit below average, the runoff efficiency in the spring when it started melting was actually really high because the ground is already wet underneath it. So more of that water actually went into the creeks and streams and lakes. This year, if all else stays the same, some of the water from the snowpack would initially going into moistening up the ground, and then it would start running off into the creeks and streams. So a little bit different dynamics there at this point. So lots going on. All right, let's take a look at the weather outlook here. There's my friend the rattlesnake at Hidden Valley. I was out doing a run, a little bit off trail, admittedly, and came around a curve and heard the buzzing noise and like, whoops. And so we had a little chat about surprising each other. But, bottom line is anything sinister, like my friend there, lurking for this winter. And so when we look at outlooks, when we look at long range outlooks, week out, 4 weeks out, months in advance, in meteorology, we use a technique called ensemble modeling. Instead of just running one simulation into the future and coming up with one best guess, what we do is we run a litany of simulations. It could be 50, 100 or more simulations with slightly different initial conditions to account for the unknowns in the current atmosphere, and then running those into the future, and then coming up with a range of possibilities into the future. And this is kind of what this schematic says. So this ensemble technique can show us a range of feasible scenarios going forward. So it helps us prepare better for potential extreme events or assessing the likelihood of events. And that's information that we in the Weather Service communicate to decision makers, emergency managers and such. Also from this data, we can glean probabilities for various events occurring or thresholds being met. Like how many of these models show us having a foot of snow by this time next week? And so that gives us a sense of confidence levels, right? So we use this ensemble technique in a lot of our long range forecasting. And actually, we even use it in short range forecasting, like when it comes to thunderstorms and fire weather. We use high resolution ensembles that can help us gauge what is the probability of 60-mile-an-hour winds at Reno, for example, in the winter storm coming up. So we can use that kind of data to assess that. So, and you'll kind of see this later in my presentation. We're kind of getting away from just giving you that one number forecast, but also providing the range of possible outcomes is of value to a lot of people out there. All right. So with that in mind, let's take a look at the next couple weeks, and then we'll kind of start working our way forward into the future. So this is from the European Center Ensemble, and look at the precipitation outlook. And this first diagram here shows you the probability of 1/10 of an inch or more of water equivalent through December 28th, so roughly the next 2 weeks. So basically, the European Center runs about 52 different simulations, and what percent of them indicate at least 1/10 of an inch of water equivalent? Well, in our area, they're pretty good. And a lot of this would actually occur next week. This current week is largely into the weekend. It's going to be cool and dry, relatively dry. But next week around Christmas, we could start seeing a little bit of an uptick in the storm activity. But okay, 1/10 of an inch, that's nothing really interesting, especially in the middle of winter. So about 1 inch. What about 1 inch? That's where we start talking real accumulation there. So 1 inch of water equivalent to December 28th. Well, the probabilities definitely drop, but they're still non-trivial around Tahoe and the Northern Sierra. So anywhere from 30 to 50% chance between now and about 2 weeks from now, seeing at least a 1 inch water equivalent pickup from storms. And again, we're kind of eyeing that right around Christmas, maybe a shortly after period, where we could see some storms. But look at the Pacific Northwest, much higher probabilities for seeing those heavier precipitation storms. So again, this is the power of ensemble forecasting, is you can calculate these probabilities. All right, so this is on precip. So yes, the storm door does start to open back up next week, but the question is, how big will anything be when it comes through it, at least at our latitude? If you're further north, if you're up in Seattle, it's almost a done deal. You're going to see a significant, at least one significant storm in the next couple of weeks. Let's look at temperatures. Everybody with their utility bills, they're really interested in temperatures. I've done a few interviews on that recently. So same ensemble modeling system, but here you're going to see slightly different graphics. This is taking the average temperature anomaly for the next 7 days. So we're taking all those 50 different models and kind of averaging them all together, sort of a middle of the road. And it definitely shows us remaining cooler than normal, especially off to our north and east into the Great Basin, and just some really impressive cold up in Montana. So if you have any travel plans to Montana, it's going to be really cold up there as we get toward this weekend and honestly most of next week. And then that cold air is going to spill southward toward Denver and Chicago and into the Midwest. Very cold, possibly one of the colder air masses we've seen in many years. Now further out the next 2 weeks, so roughly the 22nd through the 28th, here we do show a moderation trend. A little bit more of a wind pattern shift, a little bit more mild Pacific air coming at us. So temperatures do go near normal, maybe slightly above normal. Again, this is an average of all those ensembles. But look at that cold air entrenched in the Rockies. So along these lines, this is actually a really powerful example of why do we use ensembles instead of just one best guess simulation? Why do we use 50 different models, 100 different models? Well, let's take a look at the deterministic European model for the morning of December 23rd. Okay, so I think that's next Friday, right? A week from Friday. All right, and so this first map is the temperature anomaly for that day from that best guess single deterministic forecast from the European model. This is from this morning's forecast, and look at the temperature anomalies over us. Pretty warm than normal. I mean, 5-10 degrees Fahrenheit above normal. But look at this cold air up in look at that Montana, the Dakotas, British Columbia. I mean, 50 degrees below zero anomaly. So if their average temperature is 20, which I'm not sure what it is, that means minus 30 Fahrenheit. I mean, just amazing cold. I know most of us, we're mountain people, right? We're thankful for any mountain ranges. We love the Rocky Mountains too, right? Just as much as we love the Sierra. This is why I really love the Rocky Mountains. It blocks that cold air from coming down here most of the time. Sometimes it can sneak through, but a lot of times the Rocky Mountains blocks that Siberian and Canadian cold air from getting down here, because cold air is more dense. It's going to stay closer to the ground. It's heavier. And so it has a hard time kind of getting lifted up and over the mountains and into the Great Basin and areas like that. Well, that's this morning's forecast. Here is the forecast from yesterday's deterministic European model, just that one model for the same time period. Holy cow. This is all over weather Twitter. People are like, there's no way this happens. But look at that. I mean, 35, 40 degree temperature anomalies for us. I mean, this would be devastating cold for us. And so this is why you don't look at just one model simulation when it comes to the long term, because they flip flop all the time. So that's the power of 50, 100 member ensembles, is it tends to keep things a little bit more on the train tracks. You're still aware of the extreme scenarios, but when it comes to long range forecasting, you don't want to do back and forth all the time. You kind of want to trend in certain directions. So anyway, I was happy to see that the right hand side seems to not be still in the models today. But anyway, all right, let's move on. Atmospheric rivers. This is winter's moisture trap. This is when we get most of our significant precipitation. These are really beneficial for us. These are those big plumes of moisture that come off the Pacific Ocean. The old term Pineapple Express still applies, but atmospheric river is kind of the new term for them, effectively the same thing. But these streams of moisture from the tropics that come into California and the Sierra and Nevada, they're really beneficial. They bring a good chunk of our snowpack and water supply for the year. But if we get too many of them or they're too intense, that's when we get our hazardous weather like flooding is an example, or the major blizzards. So what is the outlook for atmospheric rivers? And so the folks at the Scripps Center for Western Weather and Water Extremes have basically started up an atmospheric river program. I mean, they have PhDs working on this stuff. And so one of the products that we use a lot, you've seen this, is the atmospheric river landfall probability chart. And this is, again, derived from all those ensemble members, all those different simulations. And so this shows what percent of those simulations indicate an atmospheric river landfall at various latitudes on the West Coast at various times into the future. And this is from the European Center Ensemble model. So this goes with some of the data I was showing you earlier. And sure enough, right around the 23rd, 22nd, 23rd, especially to our north up into Oregon and Washington, pretty high chances for AR conditions there. So that gives you some confidence that they're going to turn quite a bit wetter as we head toward the Christmas holiday period. But non-trivial probabilities even down to our latitude here. And so we have to keep an eye on that. That potentially opens the door to something more significant, especially around and after Christmas for us. Now that's the European Center modeling system. What about the GFS, or the American modeling system? So we look at both. They both have their strengths and weaknesses. Well, the GFS-based one actually says the probability is a lot lower, and actually maybe even a little bit further north. So this does demonstrate some uncertainty in that chance of getting a large event, a large storm, as we go toward the Christmas period. So this is why I say the storm door will open back up maybe around the 23rd. The question is anything going to come through it? And if it does, how big is it going to be? And that's still very much to be determined, and it determined on how far south that storm track gets. So there, if you need emoji annotations, there you go. I think that just about sums it up from a meteorologist's perspective. All right, this is a fun diagram that was just created this year. What are the odds of snow on Christmas Day? You know, the white Christmas calculation, everybody wants to know. So here in Tahoe, from our long-range climate site at Tahoe City, the years where you see the trees covered in white, that indicates you had at least 3 inches of snow depth. And then the trees that have no snow on them actually indicate that there was no snowfall and there was no snow on the ground. And that's actually really rare. In fact, of 67 years of record at Tahoe City, only 8 have had no snow on the ground. The most recent being 2005. Actually, there's 3 years in a row there where we were kind of, relative minimum in snow on Christmas Day. Now, how about Reno? Further down the hill. Well, it's a dramatically different story there. In fact, it's almost flipped, but only 3 out of 62 years have had an appreciable snowpack on the ground. Now, we've got a bit of snow here at my house in Sparks, but at the Reno airport where they measure the official climate site, I think it's a little bit less. But we'll have to see. Does it stay on the ground with the cold air, which it might, or does it melt a little bit each day? So we'll have to see if we officially have a white Christmas at the Reno climate site this year. But I think the odds are decent at this point, especially based on that cold weather forecast. So let's take a look further out. How about as we peek into the new year? Well, the forecast from the Climate Prediction Center do kind of indicate that that storm door could stay open as we head into that first week of January. The main question, as always, is how far south does that storm track get? Pacific Northwest, Northern Rockies almost looks like a slam dunk that they're going to stay active into that first week of January of 2023. But how far south does that storm track get? That's still very much uncertain at this juncture. So let's look at the winter outlook. So, kind of January, February, and March. March has kind of become an honorary member of winter in recent years. So, now that I'm the meteorologist in charge at the office, I can ask people to do things. And so back around Labor Day, I asked, hey, what's your gut feeling about the winter to come? So I did a survey of our staff, meteorologists and non-meteorologists alike. Well, they went with a warmer and wetter than normal scenario for the Sierra and Western Nevada. Well, so far, the wetter than normal, that's working out pretty good, but that warmer than normal, that's about as far from reality as possible at this point. Although it looked like one person did go colder than normal, so they take the win on that one. But getting into some of the science here, every single winter, it's El Nino versus La Nina. We're going into another La Nina. It's the third in a row. It's actually relatively rare in the last century to have 3 La Ninas in a row. Only occurred really 2 other times since 1950. And that's where the tropical Pacific Ocean, it's this top diagram, is colder than normal. That tends to drive the storm track further to the north, up into the Pacific Northwest. We've kind of seen that a lot this year, but fewer storms, not zero storms, but fewer storms into the Southwest. So LA, Phoenix, Las Vegas. And of course, we're in between here at the I-80 latitudes. So we go to the scatter plots here. And what does all this mean for us? Well, La Nina winters are those blue dots, and you focus on the right-hand diagram here. That's the one for the Sierra. This is comparing El Ninos, La Ninas with precipitation during the core winter months. And we've had dry La Ninas. We've also had very wet La Ninas. So based on historical data, really anything is possible. And even the 30,000 foot message about El Nino and La Nina in our region here in Tahoe, it doesn't really matter a whole lot for precipitation. Just the scatter plot just shows it right there. With that said, there is one little statistical quirk that we've noticed on the Truckee and Carson rivers, that a lot of our higher flow events, those major flood events like 2017 and dare I say 1997, have occurred in La Nina winters, specifically kind of the weaker La Ninas, where that tropical Pacific is maybe just a little bit cooler than normal. And we're kind of in a moderate to weak La Nina this year, so it's not apples to apples. But it's something that kind of is like, oh, okay, maybe pay a little extra attention to flood potential as we go into this winter season. But again, it's not a guarantee that we're going to see flooding. There have been plenty of years where we've been in La Ninas, even weak La Ninas, where we've had unremarkable peak flows on the rivers. But it's one of those statistical things that we always tell preparedness folks that maybe going into this winter, just be a little extra prepared, dust off that flood plan. Physically, we don't know why this is. So if you ask me, hey, what's the science behind this? We honestly don't know, but there's definitely something there where you see a lot of our high flow events have occurred during those La Ninas, especially the bigger high flow events, as you can see there. So what about this triple dip La Nina? We've only had two other times where we've had 3 La Ninas in a row since 1950. So what about that third winter? What did the third winter do in those other instances? Well, actually, it was on the drier end of the spectrum. Tahoe City and Bishop and Reno and Susanville, generally drier than normal. Now, one thing I didn't do in this analysis is dive into the hey, did it start wet and then go dry kind of thing? I know we're all in a cold sweat panic over last winter. Is that going to happen again this year, where we just shut down? Very much up in the air at that point. But I didn't dive into that granularity with this analysis. So let's go into the core of winter, January, February, March. Well, we're in the dreaded equal chances. I mean, anything is possible as we go through the balance of winter. A couple of months ago, I gave a talk. I think it was Carson City Public Works, and they said, hey, Chris, could you tell us something other than 50-50? And I'm like, well, I think I got you covered on this one. How about 33, 33, 34? And, of course, the room went silent at that point. But that's the truth. That is, we basically any scenarios on the table at this point. We could stay active for the rest of winter. We could go dry. We could be near normal. We are in any scenario, we are likely to have lots of peaks and valleys. We're going to have stormy periods, go dry again for a while, stormy periods. That deal is totally normal in our climate here. The question is, are we going to end up wetter than normal, drier than normal, or near normal? Anything is possible at this point. The dice are not loaded in any particular role at this point for the balance of winter. What this is kind of cool is taking that snowpack data that I showed you earlier, that time series, and saying, hey, here's where we are now, this black line. Here is normal, this green line. Here are the range of extreme scenarios for the rest of winter for snow water content in the Tahoe Basin. Well, you can take where we are now and then apply using historical analogs. What are the possible scenarios using previous winters? What are the possible kind of extreme scenarios we could see going forward? Here's the outcome. If we ended up with just a kind of a nutso rest of winter, almost a 2017 style winter, we are actually so far ahead, we would in all likelihood set new records for how much snow water content we would have in the Tahoe Basin, and by a lot, especially when you get into March and April there. Oops, there we go. I hit the little wheel on the mouse and it does that. I didn't know it could do that. All right. So, but on the converse side, if we were just to totally shut down and kind of flatline here, it'd be bad. It wouldn't be good, but it would be above probably a lot of our record low years, kind of the 2015 style winter. In fact, I think we're already above the 2015 peak in terms of snow water content. If we were to end up with an average rest of winter, this is unfortunately the lines here are basically the same color, but it's this top green line here. We would still end up above normal, above median at least on the snowpack. So we're in great shape now. But the key message is, good as things are now, there are still many different paths that we could take between now and April based on the uncertainties in the long range weather forecast. So these are points I've already talked about. As much as we started off really well, anything is on the table for the balance of winter, for our snowpack and water supplies we go into 2023. It would take a really big, like 2017 winter to totally erase the drought that we're in. The speaker tomorrow night is going to be talking about tree mortality. And there's a lot of those, hey, is there anything we can do to stop, the trees from dying? Well, honestly, we need a few winters in a row where we actually get near to even above normal precip. Having these years where we're kind of low and then boom, we have a huge winter and then we go back to drought conditions. That's not really that ideal for a lot of vegetation. Even with an average winter, some of those long-term drought impacts like tree mortality would likely continue into 2023. And then, don't let your guard down to flooding, even with that healthy snowpack going into the rest of winter. So I love this diagram. It kind of always, as much as a storm looks amazing, just a couple of weeks out, it always seems to fizzle as it gets closer and closer, right? We'll talk about the storm, but finally we've had some that have actually panned out, where maybe the horse was sort of inverted. It looked kind of sketchy 2 weeks out, and then it actually got better and better as we headed toward the event. So the phrase, all forecasts are wrong, but some are useful. I love this one because it says so much about what we're doing in meteorology right now. We're admitting that there is a finite predictability to things, especially as you get more and more detailed. And that, we have to admit that, and we have to say, hey, can we make a forecast that it's not perfect, but is it good enough for you to make a good decision? Because that is the ultimate value of a weather forecast, is for people to make good decisions. It doesn't have to be perfect, but hey, maybe this forecast helps you make a decision like, oh, I better go over the mountains today because tomorrow looks like a complete disaster. Who cares how much it snows? You made that decision based on a good enough forecast at that point. And so that's what we're getting into: scenarios, confidence levels, and probabilities. We're using all that model data, those ensemble models, to help make people make more informed decisions, not just saying, hey, here's my gut, here's my best guess, I'm just going to pick the model that I think is the most right, regardless of how likely it is. No, we're not doing that anymore. It's not the GFS versus the European model. Oh, my gut feeling says the European is correct in this case. Well, what does that mean? That's not science. Science is actually taking all the models and dissecting them and bias correcting them and calculating probabilities and scenarios off of them. And that's what we're doing in the Weather Service now. And a couple examples here is, when we brief our public safety partners, here's an example of winds. We're going to still give them that best guess, because there's still a lot of people who just want the number. Give me a number. That's all I need, and I'll take it from there. And by all means, we're happy to provide you that best guess. But also, let's throw some probability information in there. What is the chance of the wind surging and us getting damaging wind gusts of over 60 miles an hour? And so we can provide that kind of value added information, again, to help people be more prepared. And this is stuff we also add on our social media as well. Another way of looking at it is what what snowfall amount is important to you. If I give you a forecast of 0 to 2 inches, which is a perfectly valid forecast, especially down here in Reno, okay, 0 to 2, that 0 sounds great, but 2 inches, I better wake up an hour early to get to my job, right? So what are the odds of all these things occurring? Well, we can actually talk to that now. We can actually provide that information to NDOT, to the public if they call, to our school districts that call pretty frequently. We interact with Washoe schools a lot, and so that we provide this kind of data to them. So just I saw a couple questions in the Q&A, so I will return to those when I finish my talk. But go ahead, by all means, put questions in the Q&A, and we'll return to those when I finish. So let's talk about rivers. That atmospheric river that we had last year. I mean, that was just an incredible storm we had in October 2021. I mean, just the amount of rain. We are so jackpot lucky that storm didn't happen in January with a big snowpack and a cold, wet ground. Whew, that would have been flood. That would have been big flood. I don't know how big, but it would have been pretty substantial. And so going into that event, we knew the ground was really dry. So we kind of had this assumption that a lot of that rainfall would just get absorbed into the dry soils, kind of like a big sponge, right? And we'd see a little bit of a bump on the rivers. And so this is an example of that single deterministic river forecast for the Truckee River in Sparks at Vista. And so it does show that bump of the river levels going into that atmospheric river event. But we also ran the ensembles. We ran additional weather scenarios that showed some were drier, but some were also a lot wetter than what our kind of best guess forecast had at about 5-6 days out. Well, here it's showing you that range of possibilities, and sure enough, a few of them actually took the river up to flood stage on the Truckee River here in Reno and Sparks. And so this range of possible outcomes, this is stuff we briefed emergency managers to give them the extra situational awareness for what might be coming. Not only could there be much more of a spike on the river, but it could actually happen earlier. You notice the spike in the ensemble shading here actually is earlier, 12 hours earlier than that sort of best guess forecast. So what actually happened? Well, it wasn't all the way to flood stage, but the river did spike quite a bit. And so this is, again, the power of that ensemble data is it gives you the full range of possibilities so that you can be extra prepared for what's coming. Again, we admit all weather forecasts are wrong. That black line in this case was wrong, but was it, can we make a forecast that's good enough for people to make a good decision? Well, that's where this ensemble, this extra forecast data really comes in handy. So how about staying informed with the Weather Service? We want to keep you all informed of what's to come. And, when we have big events, we will go staff an emergency operations center. An example here, our hydrologist, Tim Bardsley at Nevada DEM in Carson City. Well, you're probably asking, where's your app? Well, the Weather Service does not have an app. It was this is one of those public-private sector boundary decisions that was made in DC levels of our agency, that the apps are really for the private sector. And so there's plenty of really good apps out there. I can't necessarily comment on specific ones, as I don't really, I don't know into the weeds on which ones do better, or, for Tahoe and which ones don't. Just be aware that there can be differences in the data that they're using. So if you notice that the forecast data for one doesn't match with what we're saying, they may be using different models or things like that. So just be aware of that caveat. Of course, we're big on social media, on Facebook and Twitter, I guess, as long as it exists. At NWS Reno, we post a lot of content on there. So definitely give us a follow there. Always now on our website, since we don't have an app, feel free to always bookmark our point forecast. And this is an example of that point forecast. And I can come over to, we'll do Incline Village here, and you can pick a site-specific elevation and geographic location, and you can just bookmark this. At least with iPhone, I'm sure with Android, you can make a button on your home screen. And there we go. See, the requested location cannot be found. Well, that's unfortunate. And of course, it always does that right when you're giving a presentation, right? So the other thing to bookmark is our forecast discussion. So if you just Google NWS Reno forecast discussion, you can find this. And this is a text-only narrative of what the forecasters are thinking for the coming 7 to 10 to 14 days. And every NWS office issues this. So Sacramento to the west issues these two. These are issued usually by 4 a.m. and 4 p.m. each day. We are a 24/7 operation. And so definitely quite valuable information here to, again, confidence levels, scenarios, just keeping up to date on the weather. And we try and keep them conversational, informative. And we also do discussions for aviation, climate. Actually, they're addressing is the storm door closing for winter. So there we're actually addressing what's to come. So really good narrative, no memes, no graphics, kind of old school. But hey, if you want to just take 5 minutes each day to keep up to date on the weather, the forecast discussion is definitely the way to go. Also, if you're interested, feel free to become a NWS Skywarn spotter. Across the entire nation, we have a Skywarn spotter program, and we have one out of the Reno office. While we're not out there chasing tornadoes on Lake Tahoe, we're still wanting to know what's going on with any thunderstorms in the summer or snowfall in the wintertime. So the more data that we get, the better our forecasts can get. So feel free to join our Skywarn spotter program. There is training that's offered a couple times a year. We try and do it virtually as well, because we know people live all over the place and whatnot. So you can just Google NWS Reno Skywarn, and it'll take you to this page, and you can always email our office if you're interested in joining that. It's a volunteer program, as is. It's not like you have to be around the clock or anything to be a spotter there. And always feel free to give us a call as well at our office, 8100 there. We pride ourselves on being accessible to both the general public and our partners. And so to that point, examples of how NWS Reno supports public safety, transportation utilities. We talk extensively with NDOT and Caltrans, getting them up to speed on what storms are coming, wind and snow forecasts. We talk with NB Energy and Liberty Utilities. They're on our briefing list. All the airports and schools are on our briefing list, and we'll provide specific forecasts to them to help them plan their operations and snow plowing and all that jazz. As an example, if we say a big storm's coming, a lot of times NDOT will start putting that message on their those road signs, those electronic road signs that they have on 395 and 580 and 80, and even on Montrose Highway, just alerting people, hey, snow tomorrow, be prepared, that kind of thing. So we coordinate a lot with those agencies. In terms of the rivers, we provide flood warnings and forecasts and water supply forecasts to emergency managers and water managers. So it's all the way from flooding to, hey, how much water is going to come out of the snowpack this year? And can we plan to have enough water to meet our allocations for all of our water users in Yerington and Fallon and in Reno and things like that. So wildfires, this is a big one for us. Fire weather really is our severe weather in the Sierra and the Great Basin. So we provide site-specific spot weather forecasts for emerging new wildfires and prescribed burns. So all those prescribed burns that you see around the region, they are pinging us at the Weather Service for a prescribed weather forecast, so they can determine if the winds are too strong or the humidity is too low or there's going to not be enough snow around the prescribed burns. So they use our data. They talk to us before they make those go no go decisions for prescribed burns. And then if there's a really large fire, like the Caldor fire, we actually send out incident meteorologists to be right there at the incident command post to brief those decision makers on decisions on firefighting and fire mitigation on those really large fires. And we also provide these forecasts for hazmat and search and rescue incidents. We do quite a few of those with Washoe County Search and Rescue as an example. They will ping us for weather information. So just a potpourri. This is actually just a few examples of the many public safety agencies around the nation, really, that the National Weather Service engages with ahead of weather events, because we all realize that weather kind of provides the foundation for a lot of decisions in everybody's lives. So that's what I got. There's a photo of one of our always amazing sunrises from the NWS office in our upper air, our weather balloon building there at the forecast office. And so we have a great view there. We cannot get away of the excuse we didn't see it coming. Between our amazing models and our fantastic view of Reno, yeah, we can't really say that. All right, so that's what I got. And I will stop the screen share, and that's what I got. And it did look like there's some Q&A here.
Yeah, so we have a couple questions. Are the clouds seeded in US or Tahoe?
So there at least used to be, and I do think it still goes on, a cloud seeding program run by the Desert Research Institute that's located here in Reno. We don't necessarily interact a whole lot with that program. So I can't really speak a whole lot to, are they actively doing that?
Great. Second question. We did a lecture at one point about cloud seeding, and they were doing it. Silver nitrate, I think, was the seed. Brian asks your thoughts on which weather model is the best. Lately, it seems that the Euro model is more accurate. Is that true?
Fantastic. Yeah, great question. So and this is yet another reason that we look at a lot of that ensemble guidance, is because on any given day, a different model may be the best, if you had to pick one. If you look at the statistics, the European Center modeling does tend to do better in the long run when you're looking at days and weeks and months of statistics and kind of in retrospective. But it's not always the best. I've seen a few cases where the European model is actually way too wet, especially at that week 2 period. And oh man, we're going to get slammed. And actually that's where you look right now. Whereas the GFS is drier, the American modeling system. So there's no easy answer to this one. It's really day by day. Each model can have a good day or a bad hair day. Yeah.
Great. And then this is the always important question. Given your area of expertise, what are your thoughts on global warming and climate change?
I think this is a case where, if you'd asked me 10 years ago, I'd be like, oh, this is not my area of expertise. And, I don't really want to talk about it because, we're seeing it. I mean, as a day-to-day meteorologist, it's in our face. I mean, that atmospheric river we saw last October, the sheer amount of rainfall we saw, our fire seasons are starting earlier and ending later, and we're having these fires in the middle of winter. That the heat wave around Labor Day, remember that one? Just how extreme those temperatures were. That's not normal. And so that's stuff that's like, even as a day-to-day meteorologist, to me is like, whoa, okay, it's here. It's not a climate change is, no, that's a few years down the road or a generation down the road. No, it's here, and we're seeing it as meteorologists right now. So the challenge now is adapting in terms of our models and communicating those extreme scenarios, because our models are actually getting good enough where they're identifying those extreme scenarios well in advance. So you're seeing, 117 degrees in Portland, Oregon, 6 days in advance last year. And we're like, no, that can't be no, there's no way. The model must be broken. Right. But no, it ended up basically coming to pass. And so how do we communicate that with a confidence level that is useful to decision makers when these scenarios just seem so extreme? So yeah, it's definitely the last few years, especially. I think we've hit a tipping point as meteorologists where it's like, as weather forecasters, that wow, it's here.
Thank you for that answer. That is, it's terrifying and yet important to discuss.
Yep.
So Bob Coates, hi Bob. Do you have any retrospective data for the Palmer Drought Severity Index in the Tahoe Basin?
In the Tahoe Basin, yeah. So that's something that the Western Region Climate Center, also over at DRI, maintains. And so if you go to their website, so Western Regional Climate Center, you go to the website, they have Palmer Drought Severity Index data for across the entire West, and you can dial it into certain geographical areas. Yeah.
That is great. Those are the questions that we have so far. Are there any other questions? You can use the Q&A or the chat, and I'm just going to pop my information in the chat, which is that there will be a recording. This recording will be available eventually once we get it edited down, and it will be on the website and also on the Turk YouTube channel at youtube.com/UC Davis Tahoe. You can find all of the events at tahoe.ucdavis.edu/events. And if you would like to join us this evening, the Zoom webinar link will be available on this site, or you are welcome to join in person and have a beverage or some food, and the talk will start right at 6 p.m. So thank you. So There's a couple comments in the chat.
Yeah.
Thank you for the great presentation, for an informative, engaging talk. You always do such a great talk, and we really appreciate you, Chris. And that we're glad that you're now. I need to update my contact for you. So what's your new title? What's your new
It's
title?
a meteorologist in charge.
Meteorologist in charge. Right
It
on.
gets right to the point. Yeah, yeah. So we will we'll have a new warning coordination meteorologist hired within a few months. And then, they'll kind of be the primary contact for doing a lot of outreach events, but you can't get rid of me too quickly. So I'm always happy to join and opine on the latest weather going on.
Fantastic. If you track these things at the top, we had 52 people. So at the top of the bell curve there. And thanks to everyone for coming out. Have a great day. And we hope to see you again this evening.
Okay. Take care, everyone.
Thank you, Chris. Take care. Bye-bye.